The topic to be discussed in this video is multiplexing. Before that, I will explain the importance of multiplexing technique. Suppose one device is there, one device with bandwidth is B, one device with bandwidth is B, and channel bandwidth is B1. If B1 is greater than B, therefore the signal is easily transmitted from one point to another point, because the channel bandwidth is greater than the signal bandwidth, allocated bandwidth to the signal. In that case, the bandwidth is wasted. That is the reason we go for multiplexing technique. Multiplexing is the process of combining multiple signals into one signal over a shared media. This one is MUX multiplexing. Many signals are applied here at the input to the multiplexer. Combine all the signals at the output of the signal at the output of the multiplexer. The combined signal is placed on the channel. Multiplexing is the process of combining multiple signals into a one signal. These are the multiple signals to one signal. This is the combined signal over a shared medium. If analog signals are multiplexed, it is analog multiplexing. Analog signals are like that. And if digital signals are multiplexed, the process is digital multiplexing. The digital signals, the digital information is in the form of zeros and ones. These signals are multiplexed. That is called as a digital multiplexing. Multiplexing is a technique used to combine and send the multiple data streams over a single media. Multiple data streams, that means related to digital multiplexing technique. The process of combining the data streams is known as multiplexing, and the hardware used for multiplexing is known as a multiplexer. Generally, multiplexing means combined many signals into one signal. That signal is placed on the communication channel. Multiplexing is achieved by using the device is called as multiplex that combines n input lines to generate single output line. It combines n input lines and generates a single output line. Multiplexing follows many to one, n input lines and one output line. You see the n input lines and one output line, many to one. The advantage of multiplexing is that we can transmit a large number of signals to a single medium. This channel can be a physical medium like a coaxial, metallic conductor, wireless link, and we have handled multiple signals at a time. The cost of transmission can be reduced. This is the channel. The channel is either coaxial cable, already mentioned here, coaxial, metallic conductor. Sometimes wireless links are also used as a channel, send the information from one point to another point. The main aim of that multiplexing technique is effective utilization of channel bandwidth. Channel bandwidth, the one of the important resource of the computer communication networks. If the channel bandwidth is effectively utilized, therefore communication is also effectively utilized. That is the reason we go for multiplexing technique. Here, the n input lines are transmitted through multiplexer. These are the n input lines, and the multiplexer combines the signals to form a composite signal. The multiplexer function is combine all these signals to form a composite signal, one signal. The composite signal is passing through the channel. A demultiplexer and demultiplexer separate the signal to component signal and transfer them to their respective destination. The main function, the composite signal is reached to demultiplexer, passing through this demultiplexer and extract the original and output lines, which are whatever the input lines are available here. These lines are extracted at the output of the demultiplexer. Two types of multiplexing techniques are there. Frequency division multiplexing. In frequency division multiplexing is an analog technique that can be applied when the bandwidth of a link is greater than the combined bandwidths of the signals to be transmitted. These are the mini signals here. These are the signals. This is the bandwidth of the link. Frequency division multiplexing is the analog technique. That means we use the analog signals that can be applied when the bandwidth of the link, this is the bandwidth of the link, is greater than the combined bandwidth of the signals to be transmitted. This is the signal 1. This is the signal 2. These are the n signals are there. We use multiplexing technique. Multiplex all these n analog signals and count the total bandwidth will required of these n signals, which is less than the bandwidth of the link. When the bandwidth of the link is greater than the combined bandwidth of the signals to be transmitted. Here bandwidth is playing important role. In FDM, signals generated by each sending device modulated at different carrier frequencies. This is the signal generated by a source 1, where that frequency of that signal is very low value. That is the reason high carrier frequency is the high value. With the help of that carrier frequency, some modulation is done on this signal. This is the signal. After that only the modulated waveform is transmitted. In frequency division multiplexing, signals generated by each sending device modulate different carrier frequencies. This is the carrier frequency, is the high frequency wave, which is which is combined with the low frequency wave. A modulation has been takes place. After that only send the information from one point to another point. These modulated signals are then combined into a single composite signal that can be transported by link. Carrier frequencies are separated by sufficient bandwidth to accommodate the modulated signal. These carrier frequencies must be separated. These bandwidth ranges are the channel through which various signals are traveled. It is an analog technique. Frequency division multiplexing is a technique in which the available bandwidth of signal transmission media is divided into several channels. This is the bandwidth of the channel. Bandwidth of the channel. The bandwidth of the channel is divided into several channels like that. Which available bandwidth of signal transmission media is subdivided into several channels. This is the channel 1. This is channel 2, channel 3, and so on and so forth. This is the channel N. In this case, device 1 uses channel 1, device 2 uses channel 2, device 3 uses the channel 3. The entire bandwidth of the channel is divided into different subdivided channels. Subdivided channels, several channels. In the above diagram, in this diagram, a signal transmission media is subdivided into several frequency channels, and each frequency channel is given to different devices. This is the channel 1. This is the channel 2, channel 3. These are the subdivided channels. And each frequency channel is given to different devices. Channel 1 is allocated to device 1. Channel 2 is allocated to device 2. Channel 3 is allocated to device 3. Device 1 has a frequency channel of range from 1 to 5. Frequency range is from 1 to 5. Some guard band is there. Avoid the overlapping of these two channels. Channel 2 frequency range is from 7 to 12. Channel 3 frequency range is from 14 to 19. In between channel 1 and channel 2, some guard band is there. Channel 2 to channel 3, some guard band is there. Due to that guard band, these signals are not overlapped. The input signals are translated into frequency bands by using modulation techniques, and they are combined by a multiplexer to form a composite signal. Okay, suppose a signal is generated by a source with frequency is FM. Another carrier is used to modulate the signal. Carrier frequency is FC. After modulation, three frequencies are generated: FC and FC plus FM and FC minus FM. One carrier frequency and two sideband frequencies are generated. The input signals are translated into frequency bands by using modulation. This is the input signal is generated into frequency bands by using modulation techniques, and also uses carrier frequency. And different signals are used here. All these signals are modulated and then only combine these signals, and they are combined by multiplexer to form a composite signal. The main aim of the FTM is to subdivide the available bandwidth into different frequency channels and they allocate them to different devices. That means channel 1, channel 2, channel 3, and channel N. These after division, these channels are allocated to device 1, device 2, and device 3, and so on and so forth. Device N. Modulation technique play an important role. The signal frequency is changed to some different frequencies with the help of carrier frequency FC, FC plus FM, and FC minus FM. Using the modulation technique, the input signals are transmitted into frequency band and then combined to form a composite signal. The carriers which are used for modulating the signals are known as subcarriers. These are the carrier frequencies. FTM is mainly used in radio broadcast and TV networks. Okay, here clearly explained in this figure. Signal 1, signal 2, signal 3, signal N. Signal 1 frequency. Signal 1 is modulated by using carrier frequency FC1. Suppose signal 1 frequency is F1, signal 2 frequency is F2, signal 3 is frequency is F3, signal N frequency is Fn. With the help of carrier frequencies, some modulation takes place. After modulation, some frequency bands are created: F1, F1 plus FC1 here, F1 minus FC1, and similarly here with the help of this FC2. Signal frequency is F2, here FC1, FC2, F1 plus FC2, F2 plus FC2, F2 minus FC2, like that. In this fashion, all these spectra are combined to produce a composite signal. Using modulation technique, that the input signals are transmitted into frequency band. With the help of that modulation, the input signals are transformed into these bands, frequency bands. FC1, F1 plus FC1, F1 minus FC1, like that. All these frequencies bands are combined to form a composite signal. Here, this is the source 1, source 2, source N. These are the signals. The signal frequencies are here modulator frequencies, carrier frequencies are F1, F2, Fn. This is the spectrum of this frequency F1. Here F2. Here here F. Here F1. Here F2. Here F1. All these are combined to form a composite. This is the composite signal. Suppose the one signal frequency is F1, carrier frequency is FC1. After modulation, at the output of the modulator have some frequency bands FC1. This one is FC1 plus F1, FC1 minus F. This is the here. Carrier frequency is FC1. After modulation, the signal it changes to this one is FC1, FC1 minus F1, FC1 plus F1, FC1 minus F1. The carrier frequency is here, FC1, signal frequency is F1. After modulation, the frequency bands are FC1 plus F1, FC1 minus F1. The bandwidth requirement is FC1 plus F1 minus of FC1 plus another F1. FC1 cancel. Therefore, the amount of bandwidth required to transmit this signal 1 over this channel is 2F1. 2F1 is less than the bandwidth of the channel. That is the reason we go for another signal 2, 3, 4. All the signals are calculated, bandwidths are calculated, and then combined, transmitted to composite signal. This is the FDM. This is the signals S1, S2, and SN. These signals are combined using channel 1, channel 2, channel 3. And the demultiplexing side, we have to extract the outputs. Advantages of FDM. FDM is used for analog signals. FDM is a process very simple and easy modulation. A large number of signals can send through FDM simultaneously. It does not require any synchronization between sender and receiver. Here, modulation play an important role. Carrier signals are play an important role. Translated bands are play an important role. FDM technique is used only when low speed channels are required. It suffers from the problem of crosstalk, means suppose bands are overlapped. The channel is divided into bands. Here the bands are overlapped, some crosstalk is produced. A large number of modulators are required, that is the cost. It requires a high bandwidth channel. FDM is commonly used in TV networks because in case of different types of signals or frequency signals are transmitted. For TV9, allocated one frequency. For TV5, allocated another frequency. For ETV, like that. All these frequency signals are combined and sent and placed on the common communication channel and finally reach to destination side. That is the reason it is used in TV networks. Another technique is called as time division multiplexing. Frequency division multiplexing is the analog one. Time division multiplexing is a digital technique. In frequency division multiplexing technique, all the signals operate at the same time, but different frequencies. All the signals are combined at the same time, but with different frequency bands are used. But in case of time division multiplexing technique, all signals operate at same frequency with different times. The channel is divided into slots, time slots. In case of TDM, in case of FDM, the channel is divided into channels, sub-channels. Like in time division multiplexing technique, the total time available in the channel is distributed among different users. This is in case this is the 0 to T1, T1 to T2, T2 to T3. These are the time slots. The total time is equal to T1 plus T2 plus T3. The total time available in the channel is distributed among the users, different users. This is the user 1, user 2, and user 3. Different time intervals, and 0 to T1 for user 1, T1 to T2 for user 2, T2 to T3 for user 3. Different time intervals known as time slot at which data is to be transmitted by the sender. Sender uses this time slots, send the information from one point to another point. A user takes control of the channel for a fixed amount of time. In time division multiplexing technique, data is not transmitted simultaneously, rather than data is transmitted one by one. Because these are the time slots. Users are used time slots one by one, not simultaneously. In TDM, the signal is transmitted in the form of frames. These are the frames having different time slot. Each frame having different time slots. Frames contain cycles of time slots in which each frame contains one or more slot dedicated to each user. It can be used in multiplex both the digital and analog signal, but mainly used in multiplex digital signals. There are two types of TDMs, synchronous Tdm and asynchronous Tdm. In synchronous Tdm is a technique in which time slot is pre-assigned to every device. Here, this is the source 1, source 2, and the source 3. The source 1 generates data like that. Source 2 generates symbols like that. Source 3 generates symbols like that. By using a multiplexing technique, combine all these informations available at source 1, source 2, source 3. In the first frame, in case of time division multiplexing, the information is in the form of frames. In the first frame, combine first slot of source 1 and the first slot of source 2. First slot of source 2, there is no data available here. Here, first slot here, not here. Here the first slot of source 1, here the first slot of source 2, first slot of source 3. In case of synchronous time division multiplexing, by using here some switch, the switch rotates continuously, extract the information from first slots of this one is the first slot, second slot, and third slot. By using this switch here, this switch is rotated continuously and extract the information from the slots. Frames are formed. In the first frame, place first slot information of the source 1, A. Place second slot information of the source 2. Place first slot information of the source, like that. In case of second frame, A, B is available, but information at third source is not available. In case of frame 3, first information is available from the first source only. From second and third sources, that information is not available. That is called as a synchronous concept of synchronous Tdm. A synchronous Tdm is a technique in which a time slot is pre-assigned to every device. In synchronous Tdm, each device is given some time slot irrespective of the fact that device contains the data or not. Here, for user A, For user A, the information is A. For user B, the information is like that. For user B, like. How to frame the frames? Each frame contains three time slots. Time slot 1, time slot 2, time slot. For first time slot, for first slot, extract the information of the source 1, that is A. For the first slot, extract the information of the source 2, that is B. Extract the information of the source source 3, that is C. This is called as a frame 1. Like that, in this session, combine all these informations. If the device does not have any data, then the slot will remain empty. In case of third one, this slot is empty. The frame 3 is the A, C only. This is empty. This is empty. In synchronous TDM, signals are sent in the form of frames. That means frame 1, frame 2, frame 3. Time slots are organized in the form of frames. If a device does not have data for a particular time slot, then the empty slot will be transited. Suppose in case of slot 3 point, the second device does not have any data to send to the other positions. That empty time slot is usable. In most popular synchronous TDM are the T1 multiplexing, ISDN multiplexing, and SONET multiplexing. If there are n devices, then there are n slots. Here device 1, device 2, device 3, and device n. Source 1, source 2, source n. Each frame contains Sn time slots from S1 to Sn. Frame 2 contains Sn time slots from Sn1 to Sn, like that. If we have n connections, a frame is divided into n time slots, and one slot is allocated for each unit. This is the one slot. In the above figure, the synchronous TDM technique is implemented. Each device is allocated with some time slot. Each time slots are transmitted irrespective of whether the sender has data to send or not. Disadvantages. Suppose empty time slots, empty information is sent from one point to another point. The time slots are wasted. Therefore, capacity of the channel is wasted. The capacity of the channel is not fully utilized as the empty slots are also transmitted, which is having no data. In the above figure, the first frame is completely filled. This one, frame 1 is completely filled. Therefore, we can say that capacity of the channel, but in the last two frames, some slots are empty. Second frame and the third frame, some slots are empty. Therefore, we can say that the capacity of the channel is not utilized efficiently. The speed of transmission medium should be greater than the total speed of the input lines. That is the reason. Due to empty time slots, an alternative approach to the synchronous TDM is asynchronous time division multiplexing. This is the asynchronous TDM. An asynchronous TDM is also known as a statistical TDM. Later I will explain. An asynchronous TDM is a technique in which time slots are not fixed, as in the case of synchronous TDM. At the input side, slots are not fixed. Time slots are allocated to only those devices which have the data to be sent. This is the device 1. Some data is there, A, B, C. Therefore, time slots are allocated to device A only. Device B, another device, device 1, device 2, there is no information is available here. Time slots are not allocated. Time slots are allocated to only those devices which have the data to be sent. Therefore, we can say that asynchronous time division multiplexer transmits only the data from the active workstation. Therefore, 1 is the active workstation. B is not active workstation because their data is not available at station 2. An asynchronous TDM technique dynamically allocate the time slots to devices. In asynchronous Tdm, the total speed of the input lines can be greater than the capacity of the channel. Okay. Asynchronous time division multiplexer accepts the incoming data stream and creates frames that contains only data with no empty slots. In case of synchronous, some empty slots are also transmitted. In asynchronous Tdm, each slot contains an address part of the identifier of the source of the data. The difference between asynchronous Tdm and synchronous Tdm is that many slots in synchronous Tdms are unutilized. Suppose A, this one is empty. This time slot is unutilized. In case of synchronization, asynchronous Tdm, slots are fully utilized. So all slots are filled with data. This leads to smaller transmission time and efficient utilization of the capacity of the channel. This is the channel. In synchronous Tdm, if there are n sending devices, then there are n time slots. In asynchronous Tdm, if there are n sending devices, there are m time slots where m is less than n. M time slots are effectively utilized with the data. Therefore, m is less than n. The number of slots in frame depends on the statistical analysis of the number of input lines. This is the device having data. B does not. B didn't have any data. Ideal one. C having data. D didn't have any data. Therefore, multiplexer in case of time slots are allocated to A and C devices only. Therefore, these two data are combined, A, C, like that. In the above diagram, there are 4 devices, but only 2 devices are sending the data. The 2 devices are A and C. Therefore, the data of A and C are only transmitted to the transmission line. Frame of the above diagram can be represented as address of A, data of A, okay, address of C, data of C, address of A, and the data of A, like that. This is the transmission line. Both address and data present. The above figure shows that the data part contains the address to determine the source of the data. With this, 2 types of multiplexing techniques are completed.